Hi, I'm Bill, and welcome to the Theater of Memory. It's nice to have you here, even if here isn't really there. At least we're together. And I think I'm going to try to make lemonade today, meaning that I'm going to show you some smaller things. Things that wouldn't show well from a stage or maybe even the end of the table. They might need some magnification. And so we will call this episode, It's the Little Things. We'll begin with a quote by Jonathan Swift. So naturalists observe a flea hath smaller fleas than on him prey, and these have smaller still to bite 'em, and so proceed ad infinitum. I don't know how he talks like that. Hurts me. But it may be true. I do know that our son, Ryan, got into macro photography and was able to show us a whole new world that happens just below our level of awareness. He assures me that these little beings are not very aware of us either. And so it doesn't matter. But let's look at a couple of these people. I said, send me a couple shots that are between the size of a pinhead and that of a match head. And so here we go. Here are some. Here's a tiny beetle. Quite tiny. More toward the size of a pinhead. Hard to spot because they don't move. Now this jumping spider, you'll notice them when they move. This is a particularly hairy one. Ticks. Some of them are real small, but they can still be pretty bad. We don't like ticks at all. And I'm sorry, it's just true. Here's a little spider that is on a very small part of a plant, and it all looks like kind of hard candy, but I wouldn't eat it. Here's a jumping spider, and the jumping spider is like the other one, except that this isn't as hairy. This is a kind of a less hairy model. I kind of like the hairy ones better, but you know, they're probably the least offensive spiders that I know of. They're pretty cute mostly, and they look you right in the eyes. This is a leafhopper, I believe, and kind of cute. You never see them up close enough to actually scrutinize them. And this is a fly that is down on its luck. And you can tell because if you look under its abdomen, you can see that there are some fruiting bodies or something of fungus that has inhabited him or her and made their eyes look psychedelic or something. I don't know. That may not be the same thing. It may just be stoned. I don't know. I can't tell. I'm not a scientist. What I do know is that all of these tiny creatures are around us, and especially in Florida, what could well have been called Faunada. In the summer, they are everywhere, and we don't notice them. But they get so much smaller than that, even though the average size of a life form on Earth is housefly size. That's right, only housefly size, and that's with all of the charismatic megafauna, the giraffes and the hippos and the tigers averaged in. Not to mention the female blue whale, the largest animal that ever roamed the earth. You know, her tongue alone weighs more than an elephant. Certainly a female elephant, probably not as much as one of the really big male elephants of either Africa or Asia. But as big as an elephant. That's good enough, isn't it? I thought so. So you average in these really big creatures, and you think, well, there must be some very small creatures, and yes, indeed, there are. And some, for instance, would be bacteria. Bacteria are quite small, and they are ubiquitous. They are everywhere. In fact, our own body has 100 trillion bacteria in it, which is kind of astounding when you think that Our human cells only number about 10 trillion. So 10 times as many bacteria, but they are so very small that they comprise maybe 2% of our body mass. So if you weigh 100 pounds, only 2 pounds are bacteria. So I hope that's a great consolation to you. Bacteria, small as they are, still have about 90 billion atoms in them. 90 billion. The size of an atom, that they're using this as the sci-biz analogy these days, is if you were to take an orange and blow it up to the size of the Earth, the atoms would still only be the size of cherries. And that would just be the outer electron orbit. You'd have to take that cherry, blow it up to the size of the Astrodome to have the nucleus now the size of a grain of salt hovering over the pitcher's mound or second base or shallow center field. That's not important. What's important is they are now breaking these pieces into smaller pieces, quarks and leptons and gluons and so ons and so ons and so ons. And what's amazing to me is that when it gets down to the subatomic level, the quantum level, new rules start to apply. First of all, it's hard to pin these things down, not just because of the very tiny pins you need, but because they are more like events than they are objects. And for this realm, the quantum realm, new rules were devised. One is the observer determines what is seen. Another is if an event goes unobserved, it may not have happened at all. You know, if a physicist falls in the forest. Okay, that's not fair. There are no physicists here to defend themselves, but I just think it's quite amusing to think of a realm where they say that consciousness itself is the energy of the quantum bond. What does that mean? I don't know. That's a whole nother show. I'm just trying to show things get really tiny, really tiny. So, what does this have to do with the theater of memory? Oh, good question. I'm glad you asked, because there are only some things that are collectible. And let's get back to the realm of normal things. And I will show you these. This is beach sand. Some of it done by Professor Greenberg. Some of it just done and posted on the internet for the fun of it. I believe that they're probably curated collections, meaning this is not just a random scoop of beach sand, but this is what comprises, along with little chunks of silica, no doubt, and tiny chunks of big shells. This shows that there is a whole nother level of life at the beach, of which we are unaware. So, this is another photograph. These are photographs, like Ryan's photographs. What can we say about collecting photographs? It is fine, and it is a wonderful and worthy pursuit, especially if you take them yourself. Good heavens, what a way to learn the world and share it with people. However, in the theater of memory, we try to have objects as well as objet d'art. We try to have artifacts and what I call geofacts, because they are among the most exciting items that I find anywhere. I will show you one right here. It would be this. See, it's kind of a pinky orange Australian rock. If you could see it real close, you would see that it has little sparkles in it. This is from near the Murchison River in Western Australia, and it is 3,100 millions of years old. 3,100 million years old, which is very impressive and makes it worthy of collection. But the sparkles in it have been removed, processed, and put into a little envelope in which they look like silt down in the corner, but they are really zircons. The zircons must be blown up to about 200 times their own size to be really visible. And so this is amazing because the zircons themselves are 4,200 millions of years old. If the Earth is only 4,600 of millions of years old, this is really old stuff. You know, stuff doesn't do well on Earth. Meteorites come to Earth and immediately they start to deteriorate because the atmosphere of Earth is caustic. Oxygen, good heavens, starts to make these things deteriorate right away. Plus the atmospheric conditions that are extant everywhere. I will say that some of the metallic meteorites do better in the higher altitudes where erosion is limited to an occasional mist from the sea than they do in the jungle. They pretty much disappear quickly there and become just part of the Earth. I love these rocks. 4,200 millions of years old, and you don't see them everywhere. And to have this, Dr. Alan Nutman, who married a childhood friend of mine, did the work on this. He found these, they call them detrital zircons because it's detritus. It's what's left of another matrix. These were hard. These had a structure that kept them from dissolving, these little crystals of zircon. And so they lasted while the matrix in which they appeared dissolved. This is just the most recent matrix. This is, what did I say, 3,100 millions of years old. These are 4,200 millions of years old. But the secret is they're looking for the original matrix from these zircons. And whoever finds that will be the big dog in geology for some time to come. You know, I'm such an embarrassing nerd of guy. I get really excited about some things that will make other people go. Nevertheless, it's who I am. And I want to tell you a story. It seems like a long way around to tell you the story. So I'll fortify myself here with a little espresso. Espresso, you didn't think normal people talk like this. So, 65 million years ago, or so the story goes, there was an impact, the cosmic impact that happened that was so intense that it changed the world forever. And they say that 99.999% of the life on Earth disappeared, leaving a very small fraction to come back. Now, it is true that when these old megafauna like dinosaurs disappeared, then these young, small, hairy mammals that were able to hide during this time and able to forage enough for their little bodies were the ones who ended up thriving and taking over as the nuclear winter ended and a new world began. I've long been fascinated by this story. And I always wanted a dinosaur. And they're hard to come by, as you know. Well, I don't know if you've ever tried to find one, but they're hard to come by. And I can't even seem to find mine right now. But I'll have to show it to you later. The more important thing is for me to... No, I can show it to you now. I think it's over here. You know, it's always my problem. Where did I put my dinosaur? Here it is. Here's my dinosaur. Here it is right there. Can you see it? Yep. It's just a tiny thing. I have to say, it was very expensive for my budget, but it was from a place in China that found a deposit of shale within which there had probably been a bend in the river where a bunch of dinosaurs who died ended up in the mud. And they have been mining this shale for some years. And here's the book all about it. Unfortunately, it's in Chinese, so I can't read anything, but I can look at the pictures. And the pictures look very much like mine. My beast. But it was at 65 million years ago that this whole world changed. And that world changed because of the impact of a comet or something 6 miles in diameter. I'll talk about that in a minute. But what has always been kind of the proof that they've used in these theories is that there is, at a certain level in the record, a lot of iridium. Iridium, I think, happens off planet. It doesn't happen as much here. And so it got somehow came in, was atomized, went into the atmosphere, and came down as a layer all around the world. Not a lot, but enough to be able to tell the story. And I was lucky enough to get some from, this is called the KT boundary. I don't know, it's the Cretaceous is the age here, and the Tertiary is the age here. And then right there at that Cretaceous Tertiary boundary, which they call the KT boundary for some reason, the KT boundary, there is this layer of iridium. Somebody found it someplace. This is found in Trochu, Canada. This was found in Bidart, France. This was found in Agost, Spain. Stevensky, Denmark. And Quagliotti in Italy. All different kinds of dirt rocks that just have a high content of iridium. And you don't just buy these on the corner. You have to get them from somebody fairly reputable to know that you're actually getting iridium. Iridium isn't that graphic, I will say. It's not that impressive to look at. It is redolent of a time in between things. In between the Cretaceous, when dinosaurs ruled, and the Tertiary, when a whole new kind of life sprang up. So, fast forward to 6-8 months ago, and the New Yorker, which is one of the few magazines I read these days, had a nice article by Douglas Preston about this young paleontologist who had found something spectacular. That's his picture there. He's the one on the right. His name is Robert De Palma. And he was just a PhD candidate, not even a PhD, not a professor, untenured, and to the look of him, just kind of a kid. And he figured this out, that there would be on the Hells Creek out in, is it North Dakota or South Dakota? This layer happens in several places where the layer is there everywhere, but it only comes to the surface in some places. And one of these places is in Hell's Creek, so he rented some land, leased some land, and he looked for it. And let me read you just a little bit. A few years ago, scientists at Los Alamos National Laboratory used what was then one of the world's most powerful computers, the so-called Q machine, to model the effects of the impact. The result was slow motion, second by second, false color video of the event. Within 2 minutes of slamming into the Earth, the asteroid, which was at least 6 miles wide, had gouged a crater about 18 miles deep and lofted 25 trillion metric tons of debris into the atmosphere. Picture the splash of a pebble falling into the water, but on a planetary scale. When the Earth's crust rebounded, a peak higher than Mount Everest briefly rose up. The energy release was more than that of 1 billion Hiroshima bombs, but the blast looked nothing like a nuclear explosion with its signature mushroom cloud. Instead, the initial blowout formed a rooster tail, a gigantic jet of molten material which exited the atmosphere, some of it fanning out over North America. Much of the material was several times hotter than the surface of the sun, and it set fire to everything within 1,000 miles. In addition, an inverted cone of liquefied, superheated rock rose, spreading outward as countless of red-hot blobs of glass called tektites, and all of them blanketed the Western Hemisphere. Now, we've talked about tektites before. These are created, they're glass spheres, usually droplets. When anything is droplet, anything that's liquid turns into a droplet, it's usually spherical. Things want to sphere. And so it liquefies silica, and in this case, it would travel back up the vacuum tube that a body drags in from outer space at 43 or 44 miles a second. There's a vacuum tube that's dragged in. This gets sucked back up, these droplets, which are molten, and get cooled as they go up and out beyond the Earth's atmosphere. Then they circle the Earth. They orbit the Earth in such an orbit that is capable of decay, because over a period of time it does decay, and they come back into the Earth's atmosphere and they land, but in such a perfect east-west pattern that geologists can cross it with a 90-degree angle and figure out what the pole star was at the time that they landed. This is remarkable stuff, and I have to admit being absolutely fascinated by it. So I've loved tektites. I care about tektites far too much. Now, here comes this gentleman, this kid, this young doctoral student who figures out that the dust from the impact of this meteor or comet would have been everywhere. It would have been like a mist that went everywhere. And so he finds an exposed place in the Cretaceous-Tertiary boundary. He puts a lease on it and he starts looking. And by gosh, he found it. Now, this is small. This is really small. So I had to take a picture to show you that that little vial there is from the KT boundary, what they call the glass-rich burn layer from the Hell Creek Formation. And this one is from Montana. So this is another place where that boundary surface has come to the current surface of the Earth. How fun is that? These little pebbles of glass are remarkable reminders of what happened 65 million years ago. Now, it's not uncommon for this liquefied silica. This happened to be as a mist, and so the tektites are very tiny. But what's interesting is that it happened when the astronauts went to the moon. They found that the surface, the dust was a little slippery, or so they reported. And when they came back, they vacuumed all of the material out of the spacesuits, looked at it under a glass, and it was very, very small and microscopic pieces of glass that what we call tektites on Earth, but on the lunar surface they are just the result of many, many, many meteorite and micrometeorite hits. But I love this. Some of these microscopic and near microscopic pieces had their own craters in them from other microscopic hits. Now, that sand from the moon, that dust, that cheese is some that I would like to have in my refrigerator. So, what you're seeing here is a much magnified piece of lunar breccia. Breccia is a sort of stone that happens to be a conglomerate that is glued together, I think, through the process of heat and shock because of a cosmic impact. Well, that's one way it can be a breccia. The breccia that you see here came from the impact of some cosmic body into the moon at some point in the nebula's past, and it was expelled from the weak lunar gravity and was caught into the gravity and came down what they call the gravity well of the Earth itself. It landed as a meteorite, and it was found, we think, in Algeria, but sold in Morocco. And the experts said, whoa, this is the piece from the moon. And everybody said, no, come on, I don't think so. But then Neil Armstrong, the first one out onto the lunar surface, was a geologist, not a military man, and filled his pockets with contingency samples. When they got back to Earth, they did the chemical analysis and found out that this meteorite was indeed part of the moon. Now, it's only a small thing here, just this little teeny piece you can see, but it's bigger than this other piece of the moon, which is tranquilityite, and it has, it's so thin that you can actually see through it. So this is probably more expensive per gram than any drug, licit or illicit, that can be found on any market on the planet. This is from the moon. So I am not complaining that I don't have a piece of lunar breccia. It's just that I have the good fortune of being able to choose my poisons, and in this case they are from cosmic impacts. If I could have something from the lunar missions of the Apollos, that would be great. Meanwhile, I have pieces of the moon in the Theater of Memory collection. My only regret is that you are not here to examine them up close with your own eyes, because that makes all the difference. Really hope to see you in person sometime soon. Meanwhile, this is the Theater of Memory, and you are one of our most valuable people. Please come around again. Bye. you.